I just wanted to demonstrate to you that some integrals can be found, well, actually, many integrals can be found in either direction, but I just want to show you roughly what that looks like. So, as you can see here, I have two curves, one in purple and one in green. They intersect in a point, but question is, what if I wanted to find this area? In other words, the area under these curves, the area between the curves and the x-axis, which is an equivalent statement. So what I could do is I could find the area this way. I could integrate in the x direction where we're finding, again, rectangles that are thin like that with widths dx. So we could say that the area is going to be equal to the integral. We're going to have the integral under the purple curve, but then we're going to have to add to it the area under the green curve. So we need to put some points in here. I know that you could solve for these algebraically just by setting y equal to 0 to find the points where these curves intersect the x-axis. I'm just going to put them in here, and you can use your algebra skills to show that they're correct. This is going to be 1, 0. This point is, 2, 1. And this point is 4, 0. You can verify that those points are actually on the curves where indicated. So if I want to find the area under the curves in the x direction, what I have to do is integrate the purple curve. Let's divide this way. So this is 0.2. So I'm going to integrate from 1 to 2. I'm going to integrate the square root of x minus 1 dx. And then I have to do the right side of this region, the area under the green curve. So that's going to be from, so we see that's 0.2, this is 4. So this is going to be the integral from 2 to 4 of the green curve, because you now know that a line actually is just a type of curve. So that's one way to find the area. We could do it this way. I'll put a box around this because this is certainly correct. But I could also do it by integrating in the y direction. Use contrasting color for that. So what I need to do now is understand that this now becomes the right curve, and this becomes the left curve, and that what I'm doing is integrating from a low y value of here, right along the x-axis, that's y equals 0, up to a high y value there. So we can see the y part of the coordinate is 1, so that's the highest point in this region, y equals 1. So I could write the integral this way, say area is equal to the integral from 0 to 1, and now I need the right function and the left function. So what I need to do actually is I need to solve for x in terms of y in each case. So let's do the purple curve. If y equals the square root of x minus 1, then y squared equals x minus 1. I just square both sides, so x equals y squared plus 1. And then for the green curve, we solve again for x in terms of y. I have y equals 2 minus 1 half x. I'm going to just rearrange this. Get 1 half x equals 2 minus y, multiply both sides by 2, getting x equals 4 minus 2y. So the right curve is this, and the left curve is that. So that gives me 4 minus 2y minus y squared plus 1. Don't forget when you actually need parentheses, you should use them, because of course subtracting that purple expression without any parentheses would have a different meaning. And since this is In the y direction, we put a dy, not a dx. So that's this is an equivalent. This integral gives the same value. I'm not going to solve both of these. I know that you would know how to calculate them. The important point is to be able to set them up like this. Sorry, I just want to make a point. If you notice, if you look at the blue integrals, in both cases they end with a dx, and the functions that are being integrated, we call the integrand, has only x in it. It has no y's. That's true here, and it's true here. If you look down here to the green integral, this ends with a dy, so I'm integrating in the y direction, and if you notice the function being integrated has only y's and no x's. In fact, this is an important principle because you can tell that an integral is wrong if it has x's and it ends with a dy. You just don't see that. If I'm going to integrate in the y direction, I have to put all the variables in the integral in terms of y. When you eventually get to multivariable calculus, you'll be able to deal with multiple variables inside the same integral, but we're not there yet. So for the purpose of this course, you should always have just one variable in your integral. If you have two, you automatically know that that integral is wrong, you've done something wrong, and you have to change something.